Phone. So I just wanted to also thank all of the Ala Wai Watershed participants, who are joining us on this call today. We haven't seen many of you in person for a long time, but we also, on behalf of our PIG, wanted to thank everyone for the supportive testimony that we have received over this last few months, as we have moved forward with our legislative budget amendments. So as we move through today's discussions, it will be great to interact with all of you once again. Thank you.
All right. Well, thank you. Well, welcome everybody. This is a virtual meeting, not something we had planned. This is some of the things that just get thrown at us as we move along, but we're going to try to do the best we can. I think for us, this is a first. We're trying to have a major community meeting online with Zoom, and so far things look like it's working pretty well. This is a status meeting, and the reason why I say that is we've had, I think the last meeting that we had was on October 1st, if you can believe it. That was the end of our first project, and that was to do the community outreach meetings. And that, I think the last one on October 1st was at Ala Wai School. But a lot has happened since then. We started taking a lot of the output or the input that you folks gave us and tried to come up with alternatives to the plan that the Corps had, and that's what we want to present with you today. Unfortunately, with the COVID-19, a lot of things sort of kind of went to hell, and things stopped. And I know even the Corps didn't stop work, but they really slowed down because they got assigned to do the design of emergency medical facilities at NBC as well as the convention center. But I think slowly things are starting to open back up. But I also felt that this is time for us to have another meeting and do status with you and let you know what things have been going on. And we really want to show you what we've been working on. This is going to be, I think, very, very interesting. We are going to show you a couple of models. The models, the model is going to be based on a 100-year storm. The first one will be based on nothing happening in terms of mitigation, and you can see how much flooding is going to occur. The second one is with some of the mitigation things that we had put in that we call SWIFT, and we'll get into that a little bit later, and you can see what the differences is. So with that, we are going to show you a video that we've put together. I've got some slides, and I believe they were mailed out to you, and I will just walk through them with you. We'll go through the model, and then we're going to have some questions and answers. So why don't we start off with the video.
Aloha from Oceanit. The Ala Wai watershed encompasses 19 square miles from the Makiki, Manoa, and Palolo valleys down to the Ala Wai Canal and Waikiki. It is the most densely populated watershed in Hawaii, with high densities of homes, condominiums, businesses, and schools, including the University of Hawaii at Manoa. With increased urbanization and an evolving climate, storm events are becoming more frequent, and new action is needed to modernize safety and reduce flooding risks from these potentially devastating storms. But how do we take responsible action without majorly impacting the natural environment and private landowners with large-scale construction? The Ala Wai Watershed Flood Mitigation Project represents the biggest climate project in Hawaii's modern history. The goal? To reduce flood risks from a 100-year storm to prevent the Ala Wai Canal from overtopping by reducing flooding in our valleys and protecting the entire watershed. The Manoa flood in October 2004 reminded us of how vulnerable we all are to sudden and severe flood events. Over $100 million in damage was done by a flood only classed as a 20-year storm event. The 2004 rainwater flow rate in the Manoa-Palolo Drainage Canal was 9,500 cubic feet per second. In a 100-year storm, we would see flow rates up to 20,000 cubic feet per second, resulting in significantly worse damage than the 2004 Manoa storm. Damage from a 100-year storm event today would affect over 3,000 properties and cause an estimated $1.14 billion in structural damages alone. Oceanit has been working with the community to help better understand the issues so that the best possible flood mitigation solution can be attained. To accomplish this, Oceanit spent time collecting and listening to community concerns, hosting 13 stakeholder meetings with over 300 stakeholders from all levels of the watershed and from Native Hawaiian communities. A solution must take into account the protection of the Waikiki economic engine, flood reduction upstream of the Ala Wai, protection of private lands, and minimal ecosystem impacts. All stakeholders agree that flood mitigation is needed to protect Waikiki, but not at the expense of the upper and lower watershed communities. Communities were against construction of large-scale detention basins in the upper watershed, high concrete flood walls, and the loss of private property. But as a community, we remain convinced that there is a responsible engineering solution out there that respects the natural environment as well as the many stakeholders in the watershed. Community-driven input and interests led us to a design concept we call SWIFT, Subsurface Watershed Inundation Flow Technology. With SWIFT, subterranean tunnels are designed to divert approximately 5,500 cubic feet of water per second from the Makiki, Manoa, and Pololo valleys. These microtunnels, from each of the three main upper watershed areas, will divert water from surface flow directly out to sea, significantly reducing volumes flowing down into the Ala Wai Canal. SWIFT removes enough flow from the upper watershed to reduce the impact of a 100-year storm flood event to that of a 20-year storm event. And in doing so, SWIFT can address and balance the multitude of community, economic, and safety concerns involved. Over just 1 hour, SWIFT microtunnels will remove 19,800,000 cubic feet of rainwater, enough to fill almost 225 Olympic-sized swimming pools. By addressing flow in the upper watershed, SWIFT will protect the neighborhoods and entire downstream watershed, including at-risk areas around UH Manoa, the Ala Wai Canal, and Waikiki. This subterranean approach reduces the need for surface construction greatly. SWIFT prioritizes community safety while reducing the impact on the environment and preserving private lands.
All right, welcome back. I'm just going to walk through the slides that I believe all of you have received. So can we start that? Okay, like I said earlier, this is a status meeting. A lot of things have happened since our last meeting, and we've worked on alternatives and models, and we're presenting today what the current status is. And again, this is not the end-all be-all. This is going to be subject to change, but I believe this is kind of a stake in the ground for us, and we're ready to move on from this point. Okay, now in summary, we were hired by the Permitted Interaction Group of the City Council to basically conduct community outreach. What was happening at the time, and I'm talking about last summer, I believe August, September, and probably before that, many of the communities strongly resisted that original plan that came from the Corps. During the time that we were doing the community outreach, we held about 13 community meetings with over 300 people over about a 6-month period. Stakeholders from all levels of the watershed were in attendance, including some Native Hawaiian community members. At that time, the Corps had completed the federal EIS and had announced the project. What we did was we came up with a design that you saw in the video that we call SWIFT. Basically, it's the result of the community meetings and interactions that we had with you. And this is how we came up with this. What we did was we tried to come up with a visualization tool to better engage you, and so that we can communicate what some of the options are, what some of the other solutions are, and also to get more input from you. Let's talk about a little bit of background. The original objectives of this was to improve the low probability, high impact event of a 100-year storm. That is very difficult to do. In a sense, it's a very difficult concept. What we were looking at was mitigating the risk of flooding in Waikiki, basically by overtopping the Ala Wai Canal. And again, this is part of the original objectives as we started out back last fall. And the other objective was to preserve the shared funds of $220 million from the feds to come up with the $345 million for the project. Low probability, high impact. In some ways, it's hard to describe in the sense that, you know, it's almost like some of the new situations that we're having here. If we didn't lock down, COVID probably would be running rampant. But if we did lock down and we got COVID under control, anybody with 20/20 hindsight can come back and say, why did we spend all that money doing that when nothing happened? Well, in a sense, sometimes that's what this is with a low probability, high impact event. However, we saw in 2004 in Manoa that I believe this was categorized as a 20-year storm. It did a lot of damage to the University of Hawaii and at the libraries. And as you can see, you know, it even put cars up into the trees. So we went out and did some community outreach. We had 13 meetings with over 300 community members. And basically what you said was you wanted more communication. Communication not only with us, but with the state, with the city, and with the Corps of Engineers. In addition to flood mitigation, you also said you wanted some ecosystem restoration and putting more detention in the golf courses and parks. What you didn't want was detention basins in the upper watershed. You didn't want flood walls, and you really didn't want any kind of loss of private property. And I think everybody agreed that what we needed to do was to protect Waikiki, however, not at the expense of the upper and lower watershed communities. So really this came down to really about 4 major stakeholder priorities, and this is kind of how we see them. The first one on the upper left is flood mitigation, and that's basically risk reduction. The second one is protecting Waikiki, and that's because it's the economic engine of the state. In a sense, those two could be classified as one, but we split them out. In the lower left hand are the property rights and protection of private lands. And people were really upset about this. And then the last one is habitat and protection and ecosystem restoration. So those were some of the things that we were trying to deal with in terms of alternatives and trying to come up. And what we tried to do was to come up with something that would intersect with all of these. And we believe that that's what SWIFT does. So essentially, SWIFT is the Subsurface Watershed Inundation Flow Technology. It's just a bunch of words that we put together because we need names to call things. And so that's what this came up to be. I want to say that this is a concept and it's in preliminary draft, although we did try to model some of this thing and we will show you that. Basically, it's putting in a tunnel somewhere midway up the mountain and running it underground and taking it out to sea. What you really wanted to do was to bypass having to put a lot of the water from the upper and middle watersheds into the canal, running the risk of overflowing it. And so initially we saw possibly 3 tunnels, one in Palolo, one in Manoa, and one in Waikiki. Again, this is just a concept. We are still testing it. There are indications that we may not need all of that. One of the things that we're trying to test is possibly with a bigger pipe in Manoa, we may not need the one in Makiki, which would actually lower the cost of this thing, and possibly maybe not even need the Palolo one. The reason for this is when the Corps came back with some of the changes they did, they got rid of the detention basins in the upper watershed. Somehow or another, we need to take care of that water coming down because otherwise it would really just flood the lower watershed and the canal. The goals of SWIFT is to remove enough water from a 100-year event to match that of a 20-year event. And we believe that that is the current capacity of the Ala Wai Canal. We want to improve the effectiveness of doing this by minimizing ecosystem impact increasing recreational areas for access and utilization, and making sure that we maintain the federal funding. We wanted to eliminate or minimize the need for flood walls. And when we're talking about flood walls, I think originally people were thinking these were going to be 8-foot walls. I think there's still going to be a need for some flood walls, but definitely not that high, and possibly going to be built into the overall architecture of whatever gets built. We want to minimize the use of detention basins in the upper watershed, and we want to really eliminate or minimize the need to condemn private property. Now, here's the thing that kind of causes me some heartache. We went about trying to come up with a model, a 3D model of the watershed, and we actually did, and it's sitting here in the room. Unfortunately, we started doing this way before COVID, and by the time COVID hit, it was not going to lend itself to presenting to you today on an online forum. So we had to come up and do what we call second best effort, and we actually are using Google Maps, and we're modeling the flows in the 100-year event with no mitigation and one with the SWIFT tunnels. So basically, you're going to see two things. One is the 100-year event with no mitigation, and the second is going to be the 100-year event with the SWIFT tunnels in place. We're going to have some static maps of that as well, but the visuals, you're going to have two. So after we're done with the modeling, we're going to open this up to questions and answers. What I ask is that, like I've always done at the other meetings that we've had in the past, that we treat each other with respect, and we just be porno about how we do this. And I want to make sure that everybody who wants to ask a question has a chance to do that. Okay, with that, let me turn it over to Steve Wilson, who's going to walk through the model.
Okay, we're going to, as Sterling mentioned, we've got two animations, flood animations, that we're going to go through in a moment. And we've also got some flood maps. The goal in working on these things was to try to find a way to remove a bunch of water from the middle watershed directly to the ocean and bypass the lower watershed. And we implemented this based on feedback we heard from people after the Corps eliminated the detention basins in the upper watersheds and went from a detention model to a conveyance model, which put a lot more water in the lower watershed. So our goal was to try to come up with some kind of solution that would help remove some of this excess water, would protect the University of Hawaii, because we all remember what happened during the 2004 Manoa floods when the University of Hawaii got flooded. We wanted to help remove some of the water in the lower watershed. The tunnels don't, in theory, remove water from the lower watershed, but what it's doing is removing it from the upper and middle watershed and preventing it from getting to the lower watershed. So there's some benefit to be realized there. But recognize that from the point where we do our tunnel entrances, which are up in the valleys, we're not removing any of that water below the tunnel entrances, and it's raining hard. And so there's a lot of water that's being accumulated in the middle and lower watershed that you're still going to see once we go through the animations. This is not a solution that's designed to be all-inclusive. It's not a single standalone solution. This is going to be part of a bigger solution and will be incorporated with some of the features that the Corps is working on. So when you look at this, keep that in mind. This isn't, you're not going to see that the tunnels make the lower watershed dry or Waikiki dry, but it removes an awful lot of water. And when combined with other features that the Corps is working on, you'll see a much better result. So with that, why don't we go ahead and show you the first animation. So basically this is a HEC-RAS model, and we created an animation and compressed it over time. So you can see that it's starting to flood. There's a legend on the lower left-hand corner that gives you a sense of the depth of the water. This was the 100-year event, no mitigation. So you notice that looking at it, that it started overflowing first down by the Ala Wai Canal, down in the Iolani school area. And then it started overtopping up by Woodlawn Drive and starts coming down through the University of Hawaii. And you can see that there's some localized flooding in the Pololo area too. We can come back to these at any point in time, but why don't we go to the next flood animation? And this will be a similar animation, but it's in using the swift tunnels. So notice that there's less flooding in Manoa, and we've eliminated the flooding in the university area with the Manoa Tunnel. So the one benefit that we got in moving from the 3D model to this 2D model is we get to zoom in particular areas so you can see what's happening in localized areas. We can do flybys. So there are some benefits there. Let's go on to the maps and we can come back to this. So we have 3 maps. They're flood maps, they're peak flood maps, and they basically show the end state or what the water level is at peak flow. This first one for no mitigation during the 100-year event. So when you look at the legend on the lower left-hand corner, you can see that there's a fair amount of flooding that is between the 1 to 3 foot range. That's the green and the yellow. The orange and red in selected areas are 3 to 4 feet or 4 feet plus. The area that's the worst by the canal is by the golf course. There's areas by the University of Hawaii and lower campus that are over 4 feet, and some localized areas in the streams on the way down. So this is the map with the swift tunnels. So I realize it's hard to remember what you just saw and do a comparison. So we'll go back and forth, but this has less red, less orange, and there's less depth of water through the use of the tunnels. The last map will show you, it's a little bit hard to understand, but this is basically the negative or the subtraction. This shows you how much water the tunnels remove in this model that went out to the ocean and did not go into the watershed. So if you look in the University of Hawaii area, you're going to see lots of yellow, pink, lot of depth there in the water. You can see now when we come down to the lower watershed area, you can see that there's a lot of water spread out over the whole watershed that has been removed by the tunnels that are now not flooding. This will give you a sense of how much water is being removed. This shows you the depth of that water that the tunnels took out of the mountain.
Yeah, essentially, it's the water that we talked about in the video of 225 Olympic-sized swimming pools per hour, not having to go onto the land. It's going straight out to the ocean.
So I'm going to answer a couple questions, or I'm going to try. David Frankel put a question in. How do you design the tunnels so that you don't deprive the streams of the water they need 99% of the time when there's no 100-year flood? Great question. So we have what's known as a weir, and we put the weir in the stream, and the weir is like a chute. The water in the stream comes down the stream in a normal fashion. At the point where the water level increases above a 20-year storm, so the water level has gotten higher, the water in the stream spills over into the weir, and the water gets sent down the tunnel. But up until that point, the channels have the ability to handle the water at a 20-year flood, and we allow it to go through, and we're not depriving the stream of the water that would be there most of the time. All right, next question. So what about the idea of a tunnel further down by Manoa Cemetery? The tunnel in Manoa is actually below the cemetery. We've done a lot of modeling. The tunnels are all designed to take out a specific amount of water, and that's a function of the length of the tunnel and the diameter of the tunnel. We tried positioning the tunnel above the area where we have it in Manoa now, and we found that we could not remove enough water to have a favorable effect below, and the water that you see there going through the University of Hawaii actually gets exacerbated if we take the water out too early and we're not able to catch it down by the woodlawn area. So we've experimented with different sizes and different locations. And for this particular tunnel, the location that we have is the optimal location. How do the tunnels affect the aquatic life? Technically, they don't, because as I mentioned, they take water out only at the point where, through the use of a weir, when the water level gets high enough to be a 20-year flood, at which point the aquatic life is scrambling anyway. Normally, the water just flows, the aquatic life is there, and if anything, we're protecting the aquatic life by removing a lot of the water that would have caused them to be thrown up on the banks or taken out to sea or something like that. Is NOAA fine with the tunnels? So this is a very, very high-level conceptual design at this stage. So at this point, we're proving concepts. We have not gone out and done that. That's done at the design phase, which would be the next phase. So I can tell you that the tunnels, when they discharge stormwater into the ocean, the water is going to be cleaner than the water that would get discharged from the Ala Wai Canal. So our anticipation is that NOAA would actually be happier with the results, but we haven't approached NOAA. If a weir goes across the stream, how high and wide are they? It's not going across the stream, it's parallel, and as the stream level rises, then it spills into the weir, and it gets fed into the tunnel entrances. But until it gets to that depth, the only water going down the tunnel is anything that's being rained on in the tunnel entrance. So where are the tunnels built in the upper watersheds, and can we see what the entrances look like? Well, again, because this is a really high conceptual design, we're proving feasibility. We've identified locations we think are optimal, but we've not drawn those up. We can't show you what tunnel inlets look like, although primarily they're just they're a big shaft. The water naturally goes into the stream or the low-lying areas, and we're tapping into that in order to siphon it off the stream. Does the modeling of the tunnels eliminate flooding or only make the depths of the flooding in the lower watershed shallower? So the question is, are the tunnels removing enough water from the upper watersheds in order to make the lower watersheds dry? We are not removing enough water to make the lower watershed dry, and that's for a couple of reasons. The primary one is the tunnels have no impact on the rain that's occurring below the tunnel entrances. And there's an awful lot of that water that's falling in Makiki, McCully, and in Waikiki, and the tunnels aren't removing any of that water. So the accumulation, a lot of the accumulation you're seeing is the accumulation that's happening as a result of the water in the middle and rain in the middle and lower watersheds. We've tried bigger tunnels. We evaluated different sizes. We evaluated different locations. And what you're seeing here for a 3-tunnel configuration is the optimum we came up with. Now, we have, I'll acknowledge, looked at others. We've eliminated the Makiki tunnel, and we made the Manoa tunnel 2 feet bigger at 12 feet. And we found that the results were a little bit better for less money. We continued that, and we said, well, what happens if we eliminate the Pololo tunnel and make the Manoa tunnel bigger still? Well, at that point, we can't remove enough water fast enough. It doesn't feed into it fast enough. The bigger tunnel above 12 or 14 feet is no longer optimal, and the Pololo tunnel does have some benefits. So we can show you the results of those later on. We don't have those available for public viewing at this stage, but we have spent a lot of time trying to come up with the optimal size. We've determined that potentially we can remove the Makiki tunnel without any negative impact. And in fact, in removing it and making the Manoa tunnel bigger, we have more favorable results. We've tried it again with the Pololo tunnel. We get some decent results, but the Pololo tunnel does have some reasonable value. So we're not recommending that at this stage. I was talking about one of the benefits of the design of the weir system is that you install it parallel to the river. You're siphoning off water at the point where the storm level gets to be for a 20-year storm or higher, and you're sending it into the tunnel entrance. There's no moving parts. Maintenance is minimal. You get a weed whacker, you cut back on the weeds periodically, and you remove any, there's a grate over the tunnel. You remove any big things that might go on the tunnel. Otherwise, there's, unlike a pump that requires electricity, backup power, periodic maintenance, overhaul of parts and valves and things, this stuff is very low maintenance. the water won't travel down the Ala Wai fast enough to be able to feed a pump and remove enough water fast enough to keep it from overtopping without some kind of other solution. So there was another question, how about a lower entrance to the tunnels in the watershed area in order to remove some of that other water that is escaping or forming? We've looked at that. We're not done. We're in the early stages of it. But the issue that you run into is that in the upper watershed, it's steep. And so what you have is a pretty good head. By that, I mean the difference in elevation between the discharge point and the entrance point. And that head creates pressure and it pushes the water through the tunnel at a pretty good rate without the need for any pumps. When you start getting much lower in the watershed, your head differential is minimal. And at that point, you're going to have to consider possibly using a pump. I know the Corps is looking at possibly putting a pump by Houston or by Kaniwai or something like that. And you can't allow the head differential to drive the water out. You're going to have to put a good sized pump, and that has its own challenges and costs associated with it.
Words. Thank you very much for your presentation. Appreciate it. I mean, we didn't talk about cost. I know when we met earlier, we did talk a little bit about cost. Would you like to address that for the?
Sure. We'll go ahead and do that. As we mentioned when we met earlier, Mr. Waters, this is a conceptual design, and as such, there's an awful lot of unknowns and a lot of contingency. So as we flesh out the details, we expect the price should become lower, but the price right now for the 3 10-foot tunnels that run from the upper watershed down to the ocean outside Waikiki is about $710 million. If we remove the Makiki tunnel and we make the Manoa tunnel 12 foot, we make it bigger. And I explained we have better results for that. I just didn't have something cleaned up enough to show you. That cost drops to $580 million.
We hired an estimator to come up with these numbers, and being who they were, and not being totally into the project that we were in, and we did not want to, impose our biases onto them. We let them come up with the estimate, and they came up with probably the most conservative. It had the most caveats in there, and a whole bunch of assumptions. And I'm sure that as we start to go through them, we will see that they will come down. But they felt they had to assume the worst, and that's what they came up with. So we're pretty confident that this will come down. So at least we have a ceiling.
Is the Corps going to put this as part of their recommended solution? And at this point, the Corps is working on what they call an engineering documentation report. And that report is going to include the modifications that the Corps heard in all of those many meetings that Mr. Herzog had with the community. They're respinning some of their recommended solutions, but they had to lock their design, their modified design down, so they have time to do their models and estimates. And they did that lockdown before the tunnel idea was presented. So Jeff has told us that they're going to issue their engineering documentation report with the features that they're looking at right now. And they have something called a value engineering study that they do, where they're able to go back and take other ideas and they've got 2 or 3 different ideas they're going to run through a value engineering study for possible inclusion in the engineering, in the design that they have right now.
And when will the public get to see what's in the report, their report, the Army Corps report?
I think when they complete it, we don't even have access to it. And so one of the things that we wanted to be able to do was to kind of show you, one, what this looked like with no mitigation, what it would look like with just the SWIFT tunnels, and then when we integrated in what the Corps is going to come up with, and then you get a more complete picture. Right now, you're only seeing 2 sides, and again, it's because of the timing of when we're doing this thing. But we will have a bigger picture, a better picture, when they complete their study, which I understand will possibly be in June sometime.
What's your understanding of what the Army Corps is doing with the draft or the final EIS based on in 2017? Are they working with the state to try to push that through OEQC?
Based on my understanding, Dave, is I don't think the Corps is involved in that part of it. I know there is a discussion going on between the city and the state with DLNR, but that's all I know at this point. And it's been in there for a long time. We heard about it before this COVID incident occurred, and I don't know what's happened since, Dave.
So to answer a couple of questions about the timing of our engineering documentation report, as Sterling alluded to, and they participate in all of our executive leadership meetings, so he is correct in that we've completed the modeling and we've completed, we're working on the narrative for the report, and then it's got to go through a review process. And once we make sure it's gone through the review process, then we'll be able to submit it. I promise you that my headquarters elements are just as excited to see it as the public is. So as soon as we are able to submit that to our higher headquarters, we will concurrently share it with the PIG as well as the community, and we will hold a somewhat similar virtual meeting to this so that we can share it. Now, in reference to Dave Watassi's question, again, Sterling was correct in that we're not involved with the state HRS 343 compliance. It is our understanding that they can't move forward into a design phase and participate in a project because it involves state lands and state funds or city and county. There's some trigger point, and maybe David Franco can explain it better, but they aren't allowed to participate in a project unless they have a state EIS document accepted and published on OEQC. And so my understanding is the state and the city and county are still working on that based off of our 2017 NEPA document.
So if the Oceanit part is 510 million, is the Army Corps still going to come in at the 350? So we're talking, I mean, what's the chance of getting the SWIFT tunnels?
Yeah, no, that's a great question. And as Sterling and Steve Wilson alluded to, and hats off to Linyan and Ian and that team for putting the SWIFT concept together and doing the modeling on it. But it's still in conceptual. And so if you come to the federal government and say, here's a $780 million solution versus a $350 million solution, you know, it is a much tougher pill to swallow. And so what we need to determine is how can SWIFT be value engineered and maybe modified or scaled down so that can possibly replace some of the features that are in the Corps' plan. As he alluded to, we've removed the upper watershed detention basins, or at least we're pretty sure we're going to remove those upper watershed detention basins unless something changes over the next month. But we're moving to more of a conveyance project than a detention project, because similar to what their model is showing is what we were saying, if you impound, what they're saying is if you evacuate everything in the upper watershed, you still have all of the rainfall in the middle and lower watershed. And so it's a matter of finding that happy medium between evacuating the water from the upper watershed and still protecting the Kali'imaule'ili area. Can I say that there are 3 SWIFT tunnels at $780 million are going to fit in with our $350 million system of features? Just being frank with you, at this point, I would probably, at a cursory analysis, say no. But is there potential for the SWIFT to be value engineered and incorporated at some level into, Sydney, you had a great point of, well, what if we use SWIFT down further in the Kali'imaule'ili area or over in the Makiki area where it's the bottom of the bowl? That could potentially be a value engineering option, or potentially putting it up near Kanawai or up at the Palolo Manoa confluence where Dave Watasi and I and you and Cindy and I, we all walked that area and talked about similar features. So some of the concerns that need to be brought up, and I think they were brought up, but subterranean tunnels, what are the environmental impacts? What are the impacts subsurface? What is the impacts to the utilities and to the development? All of those questions, I totally understand that Oceanit doesn't have the answers to, and I wouldn't expect them to. They've been working on this for, 6 months, whereas, we've been working on this study for several years.
Want to thank you for being here. If you have any other questions, we'd like to hear from you. Please send it to us at alawai@oceanit.com, and that's what I have up here. When we do answer the questions, we will post them on a news section in the Oceanit website, and that will be at oceanit.com/news. You can go there now, and I think you will see the answers to the questions that were asked at the Ala Wai meeting back in October. But we intend to create a new section for questions that come in on this one. So please, we do want to hear from you. Okay, well, thank you very much. We're going to call another one as soon as we get indication from the Corps about when they're going to be finished. And what we'd like to do is just have another status meeting. Hopefully that will be in early July, I'm thinking. So in the meantime, if any of you have any comments or questions, please send them to us. We want to hear from you, and we look forward to seeing you, hopefully the next time face-to-face instead of virtually like this. All right?
Thank you. Thank you very much, everyone.
Yes.
Thank you all.
Good night.
Thank you. Good night.
Good night.
Good night.